Hello everyone! So it's been a year since Tinkering with Terrius started on YouTube here. To commemorate the 1-year anniversary, I decided I wanted to do a more elaborate project. So we're going to be doing a 24x6 LED matrix. Now I found the schematics and the information for this, as well as the Arduino code on instructables, and I'll link that in below in case you want to take a look at it. For this project we're going to need 144 LEDs. We're going to need 24 current limiting resistors for those LEDs, so based on what color you use, the value of the resistors will be different. I'm using red, so I'm using 220 ohms. That should give me about 15 milliamps. You're going to need one 4017 decade counter, 6 1K resistors, 6 transistors, NPN transistors. I'm using 2N2222As because I have a bajillion of those. You're going to need a very long perf board. You'll probably want it to be at least 48 holes wide because each of these LEDs is going to block 2 holes. You need an Arduino, and you need 3 74HC595 shift registers, as well as some way to connect these to the Arduino. It's got the transistors for power, the decade counter, the 3 shift registers, and the Arduino pins. So the Arduino is going to be supplying the 5 volts of power, and it's divided into columns and rows. So the transistors go to the rows, the negative side of the LEDs. The columns go to the positive side of the LEDs. I'm using sockets for the chips. It's going to make life a little bit easier, and you should be able to hopefully see here that I've already put down the ground pins and the positive rail for the chips, and I did this because I want to be able to solder these in before we start messing around with the resistors. So for the positive rail, what I've done is I've taken some heat shrink tubing, and I've taken a piece of bare wire and I've just covered it up and opened it in places where there's going to be positive pins poking up through the perf board that are going to be connected to the positive pins of the ICs. So pin 16 and pin 10 of each of these ICs is connected to VCC. That's where I've cut out little chunks of the heat shrink. Now originally I had planned to do this on a bigger perf board, but I figured that I should be able to fit it all onto this smaller 24 wide perf board, so it's going to be an adventure. Now what I'm going to also do is I'm going to use the right side bus here as a positive rail and the left side as a negative rail, just because I can. So first I'm going to solder all of these down because I don't want them to run away. So the power buses are both fully connected. So next I am going to put on the power rails. So this side's going to be positive, this side's negative. We have a bus on the side there now. It's not the shiniest or anything, but I didn't expect it would be with just how much solder there is there and how much heat wicks away. The bottom is actually quite shiny. So now we're going to connect the positive to this bus. So that's the first part of this done. Next thing we're going to do is install all of these IC holders. I'm just doing one pin on each so that we can make sure that they are level, and that one was not. 3 of the 4 IC sockets have been soldered on. Okay, now all of these pins are connected. So all of the negative pins on the inside are connected to their respective pins on the header and to the base here, and then all of the positive pins as well are connected to their correct power points. Now I'm going to install this IC holder, which is for the 4017. So these are all the shift register holders. This is the 4017 decade counter holder. Okay, so we're putting in the little pin header there, and that's going to be to connect the Arduino stuff to. So now the power rail is connected to the header right here, and it's connected to the power of this chip, which is good. This is the negative of this chip. I'm going to run a wire from here over to there. So this is about a quarter of the way done now. So I added this ground wire here from this IC on the inside, went under, came down to the header. Now all of the grounds are connected together along there. We're going to still have to connect the grounds from the transistors. So this is pin 11 of the Arduino, this is pin 10 of the Arduino, this is pin 13 of the Arduino, this is VCC, this is pin 8, and this is pin 9. So pin 8 and 9 go directly into the IC here, the decade counter. VCC goes directly into the decade counter, ground goes directly into the decade counter. These three pins will be controlling the shift registers. So I'm just popping in the transistors now. Mostly just so I know exactly where they're going to be in relation to everything else. So what I just did is bent over all of the emitter pins so that they're all connected, and this final one here I bent into this hole so that I can connect it to the ground easier. Now all we have left on the transistors is the base pin, but I'm not going to connect those yet. I'm going to connect those after we get the rest of this built. And this is the 1K resistors, which is our next component. Okay, I'm not quite done with this. I need to connect this pin to the negative. And we're going to solder these on real quick, and then we're going to figure out how to run their leads over to their corresponding transistors. So now we have the resistor legs. I left the leg on this one because I'm still needing to connect it to this pin way over here. So I just put a little bit of heat shrink over it just to make sure it doesn't short out with anything. So what I did is I ran a wire. So what I did here is I ran a wire up through this hole right here, which is the base of transistor 5, and up through the connection point of the resistor. I solder those on. I didn't record soldering on those last two transistors because they were being too difficult to do under the camera. But this is what we have now. All of the bases are connected to their respective pins. So now all that is left is connecting the ICs to the pins from the Arduino. So the logic board is as complete as I can do for now. It has the transistors installed, the IC sockets installed, all of the connections from the Arduino header installed. Basically it's good to go, except it's missing 3 resistors for the LEDs still. There's supposed to be one here, and one here. Okay, so the next portion is going to be building this LED panel. But before I can actually build the LED panel, I'm going to need to cut down this perf board to a more reasonable size. But it's going to be 24 LEDs across and 6 LEDs tall. I'm going to use the leads from these LEDs to solder to each other so that I don't have to use any wires. And then I'm going to connect the little board to this, and hopefully once the Arduino is hooked up, everything runs and works. So I sawed the board down to size just using a hacksaw. I left an extra row on the left and on the bottom just so that in case chips came out, which they did, it wouldn't damage the actual pads that I want to use. So now the next step, before doing any soldering with the LEDs, is you need to check and make sure all 144 of your LEDs light up. Just take a little button cell battery, CR2032, connect the LED, check it. If it's good, put it in a good pile. If it's bad, throw it away. The nice thing is these batteries are the perfect size and shape for testing LEDs because you can just literally pop it on there. And the internal resistance is enough that it won't overdrive the LEDs. So now we're going to cut away. I'm going to turn off the camera for a bit here while I test these. And hopefully when we come back, it will be fast-forwarded footage of soldering these onto that prototype board. So all of the LEDs are now mounted to the board. So the only reason we're soldering them to the board here is to make sure that they don't wiggle around when we start bending their leads. The negative pins all have to bend one direction and the positive pins all have to bend the other. So for the positive pins, I'm going to try and bend them fairly close to the board so that the negative pins can easily bend over top of them. So basically we're going to continue with that all the way across. For the negative leads, bend them up about that high so that they're well out of the reach of the positive leads. I continue doing that for the rest of the board. Wow, that took a long time. So here's what we've got. Everything's bent over. I soldered some of these already just to try it out and make sure it works. So we're going to go through and solder all of the board now. The cleaner method for doing this would be to cut the legs off of these LEDs a little bit further back so that there's not quite as much overlap on all of these. There's some places where there's 3 leads worth of overlap. So if you wanted to make it a little bit cleaner, you'd bend one over and you'd cut it off at the point where the next lead comes up out of the board, and then you'd continue doing that. I didn't feel like adding that extra step because as it is, this took me about, I don't know, an hour to, to bend all of these leads. So I just wanted to get it over with. It is soldered. It is complete. Almost. It needs 30 cables attached to it. Now, if you want to double check that your wiring, that all of the LEDs still work, you can just run button cell down the bars of the light, and as long as it makes contact, it lights up the LEDs along the line. Okay, so this is the finished LED matrix. You can see that I attached the wires from the board to the LED panel. We have the negative wires here. We have transistor 1, transistor 2, transistor 3, transistor 4, transistor 5, and transistor 6. Those match up here, so transistor 1, 2, 3, 4, 5, and 6. Now the tricky part that wasn't mentioned in the instructable is that pin 1 for the columns is actually this LED over here. Now originally I had thought it was this one because that's how it looked in the schematics, but that was not correct. The image was scrolling backwards and everything was wrong. So it is this LED, so pin 1 through pin 24, which kind of made a mess of the wires back there, but that's fine. Other than that, it was a very time-consuming project. It took me probably about 14 hours to get everything built and soldered and figured out. I did have quite a bit of time of troubleshooting because I had forgotten to solder the resistors to their output pins, so none of the outputs from any of the ICs were coming to the board, and I couldn't figure out why for the longest time until I realized what I had done. Then it was just a couple seconds to fix that. Now it should be working. It is a little bit difficult to read the display, so what I've found is if you put a piece of paper in front of it, it makes it much easier to read. Yeah, you can see it's quite a bit more difficult to read just with the lights lighting up, so having something to diffuse the light in front of it is a big help. Probably the most elaborate project I've done so far. Definitely the most time consuming. I think I have about 6 hours of footage that I have to edit down. Probably also going to be the longest video I've ever made. So one piece of advice I would give after building this is to use a bigger perf board for this controller board. Simply because with a 24 by 18 board, it was pushing it a little bit. There wasn't much room for ground rails or anything. It could have been a lot cleaner and tidier if I had had a little bit more space to work with. I would highly recommend using a plated through-hole board like this rather than just a regular perf board, just to make life easier, because you'll be able to use both sides of the perf board. All in all, this project has been quite interesting. I don't really know how the code works because so far I haven't really played much with Arduino code. That's one of my future plans, is to figure out how this all works. I'm sure there's ways that the code can be rewritten, but for now, this is the LED matrix and it works. So I hope you enjoyed this episode of Tinkering with Terrius. If you did enjoy this episode, then be sure to give it a big thumbs up. If you have any questions or comments, be sure to leave them in the section below, or you can email them to me or tweet them to me. Don't forget to share this video if you like it. If you want to see more of my Tinkering with Terrius videos or my Terrius Talks Tech videos, then be sure to subscribe to my channel. I try to put out a Terrius Talks Tech video every Tuesday and a Tinkering with Terrius every Thursday or Friday. And I also just wanted to say a big thank you to all of the subscribers, the viewers, everybody out there who's been watching the channel and with us on this journey so far. It's been a year and hopefully we'll be around for quite a lot longer. If you have any ideas for future projects, be sure to send those in because that's definitely helpful. So yeah, just a big thank you to all of you subscribers and viewers. You guys rock. I do this for you, and it's great to see how far we've come in the first year here. Hopefully we'll continue to grow and get a lot more viewers and subscribers over the next year here. Anyway, you guys are awesome. Thank you very much for watching. I hope you guys all have a wonderful day.